Good morning, students. Your teacher today is Dr. Bbosa Science. Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. Today, we are going to look at Group 2 elements. Group 2 elements include beryllium. The symbol is capital B, small e. Magnesium. The symbol is capital M, small g. Calcium, the symbol is capital C, small a. Strontium, the symbol is capital S, small r. Barium, the symbol is capital B, small a. Radium, the symbol is capital R, small a. So the chemistry of radium is not so much known because it is radioactive. Beryllium. The chemistry of beryllium is unique from other group 2 elements. For instance, beryllium reacts with sodium hydroxide while other elements don't. Beryllium plus sodium hydroxide, you get berylate, iron, and water. Its chlorides are soluble in ethanol, indicating that beryllium chloride has got covalent bonds, while the chlorides of other elements are insoluble in ethanol because they have got ionic bonds. 3. Beryllium oxide and hydroxides are amphoteric. An amphoteric compound is one that reacts with both acids and bases. Here, beryllium oxide reacts with acid to form beryllium salt and water. Also, beryllium oxide reacts with sodium hydroxide to form a complex ion. Reasons for uniqueness of beryllium. Beryllium has got small atomic radii. We know that down the group, atomic radii increases. So beryllium, being the first element in group 2, has got small atomic radius. It has got very high electronegativity. Again, as you are going down the group, electronegativity decreases. Electronegativity is the relative tendency of an atom to attract bonding electrons. It has very high ionization energy. Again, when the electronegativity is high, we expect the ionization energy to be high because electrons are strongly attracted to the nucleus. It has high charge density. When we divide the charge over the ionic radii of beryllium, it is higher than any other element in group 2. General properties of group 2 elements. So when you look at one electron configuration, you can say that beryllium has got 4 electrons, and that is 1s2, 2s2. Magnesium has got 12 electrons, that is 1s2, 2s2, 2p6, 3s2. Calcium has got 20 electrons, and when you divide it into energy levels, we have 1s2, 2s2, 2p6, 3s2, 3s6, 4s2. Strontium has got 38 electrons, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 3p6, 5s2. Barium has got 56 electrons, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 3d10, 5p6, and 6s2. We can see that group 2 elements end with 2 electrons in the outer shell. They have 2 electrons in the outer shell. So you can say that the general outer shell configuration of group 2 elements is NS2 because they end with 2 electrons in the outermost shell. 2 atomic radii. Atomic radii of group 2 elements increases down the group for 2 reasons. One, as you are going down the group from one element to another, the number of electron shells increase. Then B, as the number of electron shells increase, the inner electrons will screen the outer electrons from the nuclear charge. So B, there's increase in the screening effect that exceeds increase in the nuclear charge as you move from beryllium to barium. 3, electronegativity. Electronegativity decreases down the group from beryllium to barium. Reason is, as you are going from beryllium to barium, the atomic radii increase. Increase in atomic radii reduces the nuclear attraction to the outer electrons. 2, there is increase in screening effect from beryllium to barium. Increase in screening effect reduces the nuclear attraction to the outer electrons or to the valence electrons. 4, electropositivity. Electropositivity is the relative tendency of an atom to lose valence electron. The ease by which an atom loses valence electron is termed as electropositivity. So electropositivity increases down the group from beryllium to barium. Reason is, increase in atomic radii reduces nuclear attraction on the valence electron. When electrons are weakly attracted to the nucleus, they will be easy to give out. Increase in the screening effect reduces the nuclear attraction to the valence electron. Screening effect is the repulsion of the outer electrons by the inner electrons. So when the repulsion of the inner electron increases on the outer electrons, they are easily removed. So increase in screening effect reduces the nuclear attraction to the valence electrons. 5, ionization energy. Ionization energy is the energy required to remove an electron from gaseous atom to form gaseous ions. Ionization energy decreases down the group, and the reason is increase in atomic radii reduces the nuclear attraction to the valence electron. When the nuclear attraction to the valence electron reduces, the energy to remove an electron also reduces. When the nuclear attraction to the valence electron increases, it means that electrons are strongly attracted to the nucleus. Then the energy required to remove an electron would increase. Then B, increase in screening effect reduces the nuclear attraction to the valence electrons. We have already said that screening effect is the repulsion of the outer electrons by the inner electrons. So When the repulsion to the outer electron increases, then the energy required to remove an electron will decrease. So increase in squeezing effect reduces nuclear attraction to the valence electrons. In comparison, one would ask, how does ionization energy of group 2 elements compare with ionization energy of group 1 elements? The ionization energy of group 2 elements is much higher than ionization energy of group 1 elements because group 2 elements are more electronegative than group 1 elements. The sizes of group 2 atomic radii are smaller than the sizes of group 1 atomic radii. When the size is small, the nuclear attraction increases and therefore ionization energy increases. 6. Melting points. When you plot a graph of melting points, melting point against elements, we see that generally the melting point decreases down the group, and this is probably due to decrease in electronegativity. The melting point of magnesium is abnormally low, probably due to its crystal structure, but there's no agreed on reason why the melting point of magnesium is abnormally low. But if somebody wanted any answer, we can say probably due to its crystal structure. But in comparison, group 2 elements have got higher melting points compared to group 1 elements because group 2 elements have got higher electronegativity compared to group 1 elements. Let us remind ourselves about the factors affecting the strength of metallic bonds. 1. The number of electrons contributed by an atom to the formation of metallic bonds. The bigger the number of electrons contributed by an atom to the formation of metallic bonds, the stronger the metallic bond. For this reason, group 2 elements contribute 2 electrons to the formation of metallic bond, while group 1 elements contribute 1 electron to the formation of metallic bond. For this reason, the metallic bonds in group 2 are stronger than the metallic bond in group 1. So, the strong metallic bond in group 2 are responsible for the higher melting and boiling points of group 2 elements compared to group 1 elements. Then the nuclear charge. When group 2 elements lose 2 electrons, they will have 2 charges, while group 1 will have 1 charge. The stronger the nuclear charge to the electron cloud, then the stronger the metallic bonds. Then electronegativity, the higher the electronegativity of the atom, the stronger the metallic bond. This explains why the boiling point of beryllium is higher than the rest of the elements in group 2, because beryllium is more electronegative than elements in the group 2. Tendency to form complex ions. A complex ion is a metal ion bonded to small molecules called ligands by dative bonds. The tendency of group 2 ions to form complexes decreases down the group due to decrease in the charge density. A dative bond is a covalent bond where the shared pair of electrons is contributed by 1 atom only. In the normal covalent bond, each atom contributes 1 electron to the shared pair. But in the dative bond, one atom contributes both electrons to be shared by two atoms.
Mutima gwange agira ze n'essomero lyange agira ze n'emikwano gyange lino ggwanga lyange ono zabu waffe olw'ebirungi byeleeta waliyo ebinyuma laba ebiwalanfa emisono buli kimu kibeereyo tuwagire timu yaffe tugweyo tuwagire eggwanga lyaffe asobola azanya anyumisa muze yateeba agwira Dr Bbosa agwira muze yateeba
Chemical properties of group 2 elements. Oxidation state. Elements of group 2 in the periodic table have got oxidation state of positive 2, and this is because the ion M2 plus has got a stable electronic configuration of a noble gas. So elements in group 2 are unlikely to form ions in oxidation state positive 1 because ions in oxidation state positive 1 have got unstable electron configuration. Reaction with water. Beryllium does not react with water at any condition. Magnesium reacts slowly with cold water to form magnesium hydroxide and hydrogen. The insolubility of hydroxide will stop the reaction. Actually, most books will tell you that magnesium does not react with cold water. Practically, magnesium does not react with cold water. But if you clean magnesium and then you put it in water, there will be some bit of reaction to form magnesium hydroxide. But it reacts vigorously with steam to form magnesium oxide. Magnesium plus water in gaseous form, because it is steam, you get magnesium oxide and hydrogen. Calcium, strontium, barium react with increasing vigor with water to form hydroxides. So the metal plus water will get an hydroxide and hydrogen. Just substitute the metal with calcium, strontium, or barium. Reaction with oxygen, beryllium, magnesium, calcium, strontium, react with oxygen to form oxides. M plus oxygen, you get metal oxide. Barium reacts with excess oxygen at high pressure to produce a peroxide. Barium plus oxygen, you get barium peroxide. When the peroxide is dissolved in water, you get barium hydroxide and oxygen. And this reaction is used in the preparation of oxygen. Reaction with other nonmetals, group 2 elements react with halogens, nitrogen, sulfur, and halogen to form respectively halides, nitrides, sulfides, and hydrides. For example, magnesium reacts with chlorine to form magnesium chloride. Barium reacts with nitrogen to form barium nitride. Calcium reacts with sulfur to form calcium sulfide, and barium reacts with hydrogen to form barium hydrides. Reaction with acids. With dilute acids, group 2 elements form salts and hydrogen. For example, beryllium will react with any acid. For example, sulfuric acid form beryllium sulfate plus hydrogen. With dilute sulfuric acid, the reaction of calcium, strontium, and barium is temporary or immediately ceases. Why? Because calcium, strontium, and barium sulfates are insoluble. For instance, barium plus sulfuric acid, you get barium sulfate. Barium sulfate is insoluble. And then hydrogen. The barium sulfate will prevent further reaction of barium with sulfuric acid. Reaction with concentrated sulfuric acid. Metals react with concentrated sulfuric acid to form sulfates, sulfur dioxide, and water. For example, beryllium reacts with concentrated sulfuric acid to form beryllium sulfate, sulfur dioxide, and water. The reaction of barium is temporary or short. It reacts shortly with conc sulfuric acid because it forms insoluble sulfate. However, calcium dissolves in conc sulfuric acid due to formation of soluble calcium, hydrogen, sulfate, and hydrogen. Reaction with sodium hydroxides. Group 2 elements don't react with sodium hydroxides apart from beryllium. Beryllium, as we have seen earlier, reacts with hot concentrated sodium hydroxide to form berylate ion plus hydrogen. Oxides of group 2 elements, they are formed by reacting the metals with oxygen. For example, magnesium plus oxygen, you get magnesium oxide. They can also be formed by decomposition of carbonates. Uses of oxides, magnesium oxide has got a very high melting point of 2,800 degrees Celsius and is used in the making of steel furnaces. Calcium oxide is used to remove impurities during extraction of iron. Hydroxides of group 2 elements. They are prepared by reacting oxides with water. For example, calcium oxide plus water, you get calcium hydroxides. Then uses of hydroxides, calcium hydroxide is used to test for presence of carbon dioxide and it forms a white precipitate. Calcium hydroxide plus carbon dioxide, you get the calcium carbonate, which is a white PPT, or which is insoluble in water, plus water. Calcium hydroxide is also used in the preparation of ammonia from its salts. For example, calcium hydroxide plus ammonium ions, you get calcium ions plus ammonia plus water. Solubility of group 2 metal hydroxide. The solubility of group 2 metal hydroxide increases down the group. And the reason is that down the group, both lattice and hydrogen energies of group 2 metal hydroxide decrease. But decrease in lattice energy is more rapid than decrease in hydration energy. Of course, when the lattice energy decreases, solubility increases. Carbonates of group 2 metals, they are prepared by reacting aqueous solid solutions with sodium carbonate. Calcium plus carbonate, you get calcium carbonate. Uses of carbonates, calcium carbonate is used in preparation of cement, the removal of impurities in iron ore during iron extraction. It can be used as an antacid when you have like heartburn. It calcium carbonate. It can also be used as chalk. Chalk everywhere. We use chalk to write. Magnesium carbonate is used to prepare magnesium oxide. Magnesium carbonate and other group 2 metal carbonates will decompose to give oxides and carbon dioxide. Solubility of carbonates decreases down the group due to increase in lattice energy. Of course, when lattice energy increases, solubility decreases. Sulfates of group 2 metals, they are prepared by reacting aqueous solution of metal salts with sodium sulfate or the sulfuric acid. For instance, barium plus sulfate ion, you get barium sulfate, which is the white PPT. Actually, soluble barium salt solutions are used to test for presence of sulfates. Uses of sulfates, one sulfate, which is the calcium sulfate, a quarter water, is used in plaster of Paris, the one which is used to immobilize broken bones. The one which is used to immobilize broken bones. Also, the other question about group 2 sulfate is that solubility of group 2 sulfates decreases down the group due to increase in lattice energy. Quantitative analysis of magnesium, calcium, and barium, they all form a white precipitate with sodium hydroxide solution insoluble in excess. This distinguishes them from lead, aluminium, and zinc, which form white precipitates soluble in excess. With ammonia, magnesium forms a white precipitates insoluble in excess. Calcium hydroxide is very much soluble compared to magnesium hydroxide, so it is not precipitated by ammonia. So calcium will form no observable change. Similarly, barium will not form any observable change with freshly prepared ammonia. However, with oiled ammonia, barium will form a white PPT because oiled ammonia absorbs carbon dioxide to form ammonium carbonate. So the white PPT, when we add ammonia to barium, is not due to barium hydroxide, which is soluble. It is due to barium carbonate, which is insoluble. So barium plus carbonate ion, you get barium carbonate. Confirmatory reagents. Potassium chromate 6 forms a yellow PPT with barium ions. With magnesium and calcium, potassium chromate forms no precipitates. With ammonium oxalate followed by diluted acid, barium forms a white PPT soluble in dilute acetic acid, while calcium forms what PPT insoluble in dilute acetic acid, while magnesium will form no observable change. So I request you to, if you have enjoyed the lesson, you want to subscribe to digitalteachers.co.ug so that I can also benefit from this lesson. If you are in Uganda and you are looking for the best school for sciences, then you come to the Science Foundation College. You will find me teaching these things. If you have not understood, go through over and over and over until you have really understood. But you can also get the notes from Digital Teachers website. You go under A level, you see chemistry, then you see inorganic chemistry, then you'll be able to get notes on group 2 elements and other notes. Please share this website with your friends.